And then screen share. All right. So your inequality can have two different forms. Okay. Your inequality could either be in the gradient intercept form like that. So like a y equals mx plus c, but obviously with the inequation sign. Or you could have it in the standard form like that, where x and y are on the same side. And the method you'd use to shade and to plot are slightly different. So we're going to do each one separately. So the first one here, if it's in this format, the easiest way to plot it is using the gradient intercept method, all right, which is just identifying what the gradient is, which is 2, and the intercept, which is -3, and then plotting the line from there. So let's do that first. I'm not going to number the axis because that'll take too long. So -3 is the intercept, and the gradient is going up in 2s. So that means that every second square, if I have the scale is like equal on both axes, every second square will be, so that's going, if you can just see, going up along 1, up 2, along 1, up 2 every time. Okay, so that's that one. Now what we're going to do is shade it. Now I think this is the easiest format to use personally, because all you've got to say is, okay, so it's told me that y is my example here should have the symbol. So say we're sketching y as less than 2x minus 3. So if we're doing that, we're going to shade all the y values below the boundary line. So we're going to shade all the y values below the boundary. So that means that we're shading this whole region here. All right, we're going down. If it was the other way around, you would shade upwards, okay, because it's all the y values are above the boundary line. All right, so I personally think that's the simplest way. And actually, you can always use this method if you just rearrange. If you have this one, you can just rearrange it to make it into a gradient intercept version. Now, if you have where x and y are on the same side of the inequation like this, here's an example of that. You can still plot it without rearranging, and the method's slightly different. So you'd probably use the x, y intercept method to plot it to start with. So just to remind you, that's subbing in x is 0 first to find the y intercept. All right, so we're just using the equation now as if it was this is to find the boundary line. So you'd have -4y equals 12. And so y is equal to -3 because it's 12 over -4. So y is equal to -3. So the first point that we can plot is x is 0, y is -3. So 0 -3 is there. All right, and then the next one you'd sub in y is 0. So 3x -4 times 0 equals 12. So 3x is 12. So x is 4. I know you guys are all pretty good at doing that stuff, so I won't spend too long explaining that. So 4, 0 is your next point. So 4 on the x, 0 on the y. So there's your line. Again, you can use that method pretty much with every equation, but it's just easiest for the ones that are x and y on the same side of the equal sign. So there's your boundary line. So let me just put a little heading there. That's to find the boundary line. Now, I should have done a dashed line there. I've just realized. So I'm going to do that again. Just remind yourself, the dashed line is when it's a greater than symbol. And I think the example above, I probably should have done the dashed line as well, just on reflection. So there's your dashed line. Now, that's because of the greater than, so it doesn't include the boundary line. Now we've got to shade it. Now, the method for shading is a slightly different one again. So the easiest way to think about this one is to test a point. So what you do is you pick a point. The easiest point to test is a 0, 0 point. So we're going to test this point, and we're going to see if the inequation is true. And if it is true, then that is part of the shaded region. So let's have a look. So testing the point 0, 0. So 3 times 0 minus 4 times 0 is less than 12. So 0 is less than 12, which is true. Now that means that that point is required in your shaded region. So that's going to be the way we shade. All right. The other way to do it is obviously to rearrange it so that you've got, you know, you could do the y equals mx plus c format. So you'd have 3x minus 4y is less than 12. And then you could go add 4y to both sides. So 3x is less than 12 plus 4y. And then minus 12 from both sides. So 3x minus 12 is less than 4y. And then divide through by 4. So you'd have 3 over 4x minus 3 is less than y. So y is greater than the boundary line. All right, that's the equation for the boundary line as well in a different format. So y is greater than. So you know you've done it right when you've shaded upwards by looking at that as well. But yeah, testing a point will always work. And the best point to test is 0, 0, because it's going to be easiest to substitute and solve. So there's the two ways of doing sketching. So just to review, you've got your a gradient intercept format, in which case you just plot the line and then you shade either up or down, depending on which way the inequation shows. Just to correct myself there, I need to actually do that as a dashed line. Sort that out. And it's a dashed line because the example I picked was to do y is less than 2x minus 3. All right, if I'd done y is greater than, I'd have shaded the other way. The other way is to plot using XY intercept method, and then you shade based on testing a point. So you test the point 0, 0, always stick with this one. That's the best point to test, and it will always allow you to shade, and then you check if it's true. If it's true, that means that that point needs to be shaded in. So you have to shade